This is gas law calculations that are at STP. So if you have a pressure of 780.0 millimeters of mercury, we're going to call that P1. This is our temperature, 24.2 degrees Celsius. That's T1. Don't forget, we want to add plus 273 to turn that into Kelvin. And then it has a volume of, so this is V1, 350.0 milliliters. What will be the new volume? So V2 is what I'm solving for if the conditions are STP. And what that tells me is my T2 and my P2 are standard temperature, which is 0 degrees Celsius, add 273, and pressure is 1 atmospheres. Now, we have pressure in 1 atmospheres. However, this pressure is in millimeters of mercury. I want them to match, and so actually I'm going to go ahead and say instead of 1 atmosphere, we'll say 760 millimeters of mercury. So those are both going to be considered the same exact amount. So, but millimeters of mercury is what I want to use to solve this problem. Now that I have all of my variables figured out, my equation is P1 V1 over T1 equals P2 V2 over T2. So I can substitute in my information. So P1 is going to be 780.0 millimeters of mercury times V1 is 350 milliliters all over T1, which is going to be this 24.2 plus 273, which gives us 297.2 equals P2 is going to be my standard pressure, which is 760 millimeters of mercury, because I need these two to have matching units, right? So they both have to be millimeters of mercury. The volume is what I don't know, right? V2 over, and then my temperature, my standard temperature is going to be 0 plus 273, which is 273 Kelvin. So now that I have all of this lined up, I can solve my problem where I'm going to do this first, 780 times 350 times 273, and then it's divided by this number, divided by this number, because we always divide by the numbers that are associated with my variable, which in this case is V2. So when I type this in my calculator, it's going to go 780.0 times 350.0 times 273, and then I'll hit divided by 297.2 divided by 760, and that gets me this final answer. If I look at sig figs, that's 4, that's 3, that's 4, so I'm going to go with 3 significant figures for my final answer. So this will be 300 and, well, that's going to round it up to be volume 2 equals 330 milliliters. Because my V1 is in milliliters, that's how I know that this should also be in milliliters for my final answer. Here's another example. Number 2, a gas at STP. That is telling me that my T1 is 0 degrees Celsius, add 273 to make it Kelvin, and that's telling me that my P1 is equal to 1 atmosphere. Consider what your other pressure is in, and you may go ahead and use that particular unit as well. So 760 millimeters of mercury. So I got my P1 and my T1 here with my STP. This is my V1, my first volume. What will be the new volume, V2, if my T2 is 25.0, add 273 to make it Kelvin, and my P2 is 745.0 millimeters of mercury. So again, we have our combined gas law equation. And so I'm going to plug in my values. My P1 is, now look, both of my pressures, I want them to be the same unit. So I'm going to use the millimeters of mercury. So P1 is 760 millimeters of mercury. V1 is 2.00 liters divided by T1 is 0 plus 273, which is 273, equals P2 is 745.0 millimeters of mercury. V2 is what I don't know. And then T2 is 25 plus 273, which is 298 Kelvin. So now, in order to type this into my calculator, you're going to start your cross here. Remember, if my variable is this, then I want to start with everything that does not include my variable. It's 760 times 2.00 times 298, and then I'm going to divide by the two things associated with my variable, which is the 745 and the 273. So when I type this into my calculator, I'm going to have 760 times 2.00 times 298, and then I'm going to hit divided by 273 divided by 745, and I get this as my answer. So my volume is going to be, and if I look at my sig figs, I've got 3, 3, 4, so I want 3 significant figures. So we'll say 2.23 is what I'll round this off to. And that is going to be the same unit of volume as my V1 is going to be the unit on my V2.